here goes. What I wrote this. My name's Bob Schroeder, and I wrote this book, Solving the UFO Enigma, that's on slide number 1, with a subtitle of How Modern Physics is Revealing the Technology of UFOs. And I'll just get right into the presentation here. Slide number 2 is basically the thesis of the book, and I indicate on slide number 2 here that a subset of all UFO reports are real craft from extraterrestrial civilizations, and I'm just starting out with that assumption. So that's basically what I'm using as an assumption throughout the entire presentation. And but the second thing, which is very important and very exciting, actually, I think, is I believe that modern physics, and along with certain conjectures that I make, that I'll talk about, is pointing toward a very likely explanation of UFO technology. And as far as I know, there's nobody else who's making that connection between what's going on in modern physics and the UFO technology. Most people who are speculating about UFO technology tend to talk about anti-gravity or new physics, whereas I'm actually using the physics that is currently being developed, and I think that makes what I'm doing different than a lot of other research efforts that are going on out there. So we can go to slide number 3, and this is the goals of the book, and all this will make more sense as we get further into the presentation. Basically, as you can see here, I'm a man on a mission, as it says at the top of the slide there. And but what I'm up to, I'm trying to confirm if UFOs are using something called M theory and warp geometry. And we'll see what those are, those theories, what they relate to later on in the presentation. In order to do that confirmation, I'll need to monitor results from the Large Hadron Collider, the LHC, which is a particle accelerator over in Geneva, Switzerland, for evidence of extra dimensions, something called Kaluza-Klein gravitons, KK gravitons, and MBH, which stands for micro black holes. And the second thing, the second important thing of data that we need to get is we need to obtain spectrographic data from actual UFO sightings and see if we can detect something called Hawking radiation. And anyway, if A and so on the second item here, if A and B, A and or B above are confirmed, then we really do need to look at developing this technology right here on planet Earth. And if we can go to slide number 4, and this is where it gets very, very interesting. I've been studying the UFO data for decades, and one of the things I noticed when I was looking at a lot of UFO reports, I realized that these craft had a strong, attractive gravitational field around them, not repulsive. And I believe that's an important clue to their technology. But I want to make a point here that when I first started looking at the UFO phenomenon, I kind of assumed, Ben, that that it had to do with anti-gravity. I've totally changed my mind, and you'll see why, because it relates to what's going on in modern physics. And some of the indications of a strong, attractive gravity field near UFOs are the stopping or slowing of clocks. This has been reported many, many times. And another thing is objects and masses of water being lifted toward the bottom surface of UFOs. By the way, we're on slide number 5. I forgot to mention that. And the last thing is light beams being bent toward UFOs. For example, in Los Angeles during World War II, a UFO was spotted over the city of Los Angeles, and some of the searchlights that were aimed at this object, uh, they took photographs that showed that the searchlight beams were actually bent as they got close to the UFO. And then another example of this occurred up in, I think it was in Ohio, and they were doing some kind of a church celebration or something, and they had borrowed a tremendously powerful searchlight from the U.S. Army, and they were using that to kind of advertise. They were to show the location of the church. This was taking place in the evening, and anyway, just purely by chance, a UFO happened to come close to the beam of light, and again, they noticed that the beam of light bent as the UFO got close to the beam of light. And then, of course, another incident is the one that the VufoA organization down there in Australia is investigating, which is the one with Ron Sullivan. And so you guys are very familiar with that. And so here I'm just trying to give you some other examples where light beams have been bent by UFOs, and I'm sure there's others out there. So if we can go to slide number 6, and the UFO evidence is quite substantial, much more substantial than many people realize. They've actually had reports, good reports, literally from the 1930s and before, actually, right into the 21st century. But what makes a UFO are the UFO characteristics, and these characteristics are extremely interesting, and I believe they're kind of they're pointing us in the direction of the technology that these craft are using. Now, the first one I mentioned here on slide number 6 is inertia-defying rapid accelerations, and anybody who's read any stories about UFOs, they'll constantly see reports where these UFOs suddenly accelerate at blinding speed. And so just to give you an idea, there was a case out in Arizona where scientists were using theodolites to track these weather balloons. And this occurred, I think, way back in the 1950s. And they estimated that the speed of one of these UFOs, that it went from almost standing still to pretty close to the equivalent of 100 Gs acceleration. And to give you an idea, 100 Gs of acceleration is phenomenal. The best that Earthlings can do, fighter pilots, for example, in a fighter plane, as long as they have pressure suits on, is typically maybe 9 or 10 Gs, and these things were doing over 100 Gs. So that gives you an idea. It's absolutely phenomenal. Another thing is intense glow. They often have an intense glow around these objects. Again, Ron Sullivan's case, he saw exactly that. And another thing, which unfortunately I didn't add to this slide, which I meant to, they often notice strong magnetic fields around UFOs. And that's also another really important clue, I believe, to their technology. And now here, the next item here on this slide, partial or complete transparency. This is very exciting because I believe this is pointing toward some ideas and concepts that are currently being developed in modern physics. And a good example of this might be a case that occurred in France. I think it was 1986, I'm not sure the date, but it was the captain of the airliner. It was a French airliner, Air France actually, and I think they were in a 747, but he and the crew observed this gigantic circular disc, a big red disc, which, because they had radar on the plane and radar on the ground, also picked up this disc. They were able to estimate its diameter at over 800 feet. In fact, they actually think it was closer to 1,000 feet, but they didn't think anybody would believe them, you know. So, so they ended up cutting it down to 800 feet. And but here's the interesting part of that sighting, and this is the exciting part. As they were watching this object, it began to become partially transparent, and then it became totally transparent. At a certain point during the sighting, they could actually see right through this thing, in parts of it anyway, and then it eventually just totally disappeared. And the size, the diameter didn't change, which indicated something was going on. And we'll talk about what I think is going on in the upcoming slides here. And then the next item here, there's this puzzling, strong, attractive gravity field around UFOs. And the reason I say it's puzzling is because you would think they would be using anti-gravity and things would be being pushed away from these objects, but that's not the case. Instead, at least very near UFOs, there appears to be a strong, local, attractive gravity field, and that's very puzzling. But we'll see why that's happening in the upcoming slides here. And then another thing that's very significant, I think, is the consistent shapes of these UFOs. They are typically spheres, discs, cylinders, and delta shape. But even on the delta shape, like the triangle-shaped objects, they typically see these large, intensely lighted circles in each corner of the triangle-shaped UFO. So there's something about the circular shape that has to be significant. So if we can move on to, oh, by the way, the last item here, DVDs documenting actual UFO reports. Here in the United States, I normally show a DVD that shows Captain Dubach's sighting and animation of his sighting, but unfortunately I can't do that here unless I get the upgraded Skype. Sorry about that. So, but anyway, we'll go to slide number 7. And this is the interesting thing, Ben. The two big questions on UFO technology. Number one, how do they get here? That's a real big question because we're talking gigantic distances in the universe. We're talking, dozens of light years, hundreds, thousands, millions of light years. It just doesn't seem practical that any civilization could get here from another star system, at least based on the technology that we have developed, rockets and things like that. This simply, just to get to Alpha Centauri, the closest star system, would probably take hundreds of years, centuries, probably over 1,000. And so anyway, that's a big question, a big puzzle. And the second thing is, how are these craft able to perform inertia-defying acrobatics in Earth's atmosphere? And again, I emphasize that word, those words, inertia-defying, because somehow these craft are able to make right-angle turns right up in the atmosphere at high speed, which if humans were on board those craft, or on our man-made type craft and tried to do a stunt like that, would end up like pancakes on the inside of the craft. And we wouldn't be too healthy afterward. And so somehow they're overcoming the force of inertia. And inertia is the resistance to change in motion. It's the resistance to acceleration. That's what it is. And I might add, inertia is something that is not understood by modern physics, and that's another very important point. Um, as we'll see in Einstein's theory of general relativity, Einstein had something called the equivalence principle that is the foundation of general relativity. And the equivalence principle equates an inertial mass to gravitational mass. And but he called it, it was basically a hypothesis, but he did not, he and nor does anyone else, do they know what the origin of inertia is. And so if we can go to slide number 8. So the question is, on how do they get here? So we're going to focus on that question first. Of the two questions, we're going to focus on how do they get here first. And there's physicists generally believe, astrophysicists and physicists generally believe that there's basically only 3 ways that they could do it. Somehow they can travel faster than the speed of light, or they can go at near light speed, or number 3, somehow these craft are warping space-time. And just real quickly here, faster than light looks like it's forbidden by special relativity, which says that nothing can go faster than the speed of light. And the problem there is, as any object approaches the speed of light, it gains mass. Its mass goes up exponentially as it gets closer to the speed of light. So in other words, if the mass goes up, that means that because of the association between acceleration and inertia, it means you need much more energy, and the amount of energy needed as you get close to the speed of light is absolutely astronomical. It's just beyond the capability of our civilization, and probably any others for that matter. On the second item here, if they go near the speed of light, again, you run into the problem as you get closer to the speed of light. The energy needed is enormous, and just getting up to that speed is quite a technical problem as well. And when, of course, one of the other problems, even if you're able to do that and you get close to the speed of light, you end up with the problem of time dilation, where time slows down. And so any travelers from Earth, I happen to have an identical twin brother. If I which I really do, and I have identical twin sisters too. They're older than my brother and I, but we have 2 sets of identical twins in our family. And but with my identical twin brother, if I went to Alpha Centauri, from my point of view, if I went close to the speed of light, I'd be back in about 9 or 10 years. But unfortunately, my brother Dave would have aged many, many decades. And he'd be amazed at how youthful I looked when I got back. And so it doesn't seem to be practical, I'm afraid, even going near the light speed. Then there's another idea here, though. Number 3, the warping of space-time. And in the warping of space-time, there's a theory out there called, there's an idea that's being bandied about out there among scientists and stuff. It's called the Alcubierre warp drive. I don't know if anybody in the audience or Ben has heard of it, but it's a Mexican astrophysicist by the name of Miguel Alcubierre, and he came up with an idea that looks like it could work, although they found some problems with it later. But the basic idea is that you'd build a spaceship that would compress space in front of it and expand space behind it, and you do this on a continuous basis. And effectively, what would happen is you'd be surfing on space-time. It would be you'd be like on the top of a wave. You'd be surfing, and that would allow you to travel, because here you wouldn't be going faster than the speed of light. You would actually be warping space-time, and that allows you to actually exceed the speed of light in the universe, because you're compressing space-time in front of you. So it's a terrific idea. It does have one major problem, though, and that is the amount of energy required to warp space-time. It's gigantic. In fact, to give you an idea how big it is, the amount of energy you need, in order to go from one side of our galaxy to the other, you would have to basically turn about half the stars, the 400 billion stars in our galaxy, into energy for your spaceship. And now that could be a problem if some of those star systems, the 200 billion you need to convert to energy, if they're inhabited by other civilizations, and they may not take too kindly to being vaporized for us to travel around. So that appears to be an unlikely way to go. But nevertheless, these are the three basic ideas they've been talking about. But let's look at the direction of modern physics and see if we can figure out, how do these craft get here? Is there something going on in modern physics that might help us understand how these UFOs are getting to planet Earth? We can go to slide number 9. And I have to tell you that I've got good news and bad news. And the bad news, Ben and the audience there, is that we're going to have to do a little bit of physics in order to see where modern physics is going. And that's the bad news. The good news is I promise there will be no exams or tests. So not to worry. I want everybody just to sit back and relax and just enjoy the slideshow. And you don't really have to memorize this stuff. It's just basically to give you a background in what's going on in physics and some of the terms that I'll be using later in the slideshow. So in a nutshell, the universe is actually quite simple here, as we can see in slide number 9. It consists really of matter particles and force particles acting on the stage of space-time. In other words, there's only 3 basic components in the universe: matter particles, force particles, and space-time, the stage on which these matter and force particles interact with one another. And so our universe is this space-time filled with all these matter particles and force particles. And the force particles, some of which people are definitely familiar with, like a photon, that carries the electromagnetic force. And then there's other particles like gluons. They carry the strong nuclear force. And then we'll get into more detail on these force particles. But for now, I just want to give a couple of samples. And then on matter particles, many people are, most people are familiar with electrons that orbit the nucleus of atoms. And then there's other matter particles called quarks that are the subcomponents of the nucleons, the particles in the nucleus of an atom. So, for example, the proton in the nucleus of an atom is made up of particles called quarks. And neutrons, which are also in the nucleus of an atom, are also made up of quarks. So that's just an overview. It just gives you an idea of our universe and actually how simple it is. And I might add, for those of the people in the universe, I mean in the audience, they're in the universe. But in our immediate audience there, anybody who's interested in, pursuing a career in maybe a different field, or if they're students or something and they're looking for a field to get into, I highly recommend physics. And the reason is, unlike biology or botany, where you have to memorize thousands of flora and fauna, the neat thing about physics is it's pretty simple, as you're going to see in the next slide. Now remember, we just have force particles and matter particles. So if we go to slide number 10, oh, now before we go into, so anyway, I'm just going to do a little more background in physics here. This is a basic atom. It's just a simple hydrogen atom. The simplest atom possible consists of only a proton and an electron orbiting. The atom I'm showing here is a isotope of hydrogen called deuterium, and it's got a neutron as well in the nucleus, so it has an atomic weight of 2. But the simplest atom is a basic hydrogen atom, which only has a proton, a positively charged proton with a negatively charged electron circling the nucleus. And the most basic hydrogen atom that just has the proton in the nucleus has an atomic weight of 1. The atomic weight is based on the nucleons in the center. The electron is so tiny, it's only a fraction of the weight of the proton and the neutron. The proton and neutron are each about 2,000 times heavier than the electron. So that's why when they figure atomic weight, they kind of focus on the nucleus only. They call them the nucleons of the nucleus. And so as I mentioned, I have to do a little bit of physics here, but what's interesting about this basic atom is you can see some of the basic forces that are involved. You have the electromagnetic force that holds the electron in orbit around the proton. So that's what's keeping the negative electron and the positive proton together there. And as people know from putting batteries in flashlights, like repels and unlike attracts. So if you take a magnet, if you take two north poles, they push away from each other. But if you take a north and south pole, they clamp together, unlike attracts and like repels. And so that's what's going on in the nucleus. That's what's going on inside of atoms. The electron is attracted to the proton because they have unlike charges. So that's a basic atom, and in this case I just wanted to show a neutron too. So we can go to slide number 11, and this is the inside of a proton, and you can see that it's made up of 3 quarks up in the upper right corner there. There's 2 up quarks and a down quark. And by the way, the colors are kind of discombobulated here. I meant to have the 2 up quarks the same color, but I went a store here called Staples. You may have Staples in Australia too. And I could never quite get, they were the ones who did I showed them how I wanted the slides. They could never quite get what I needed. Came close, so this is good enough, I guess. But anyway, a proton consists of 2 up quarks and a down quark, and so these are the subcomponents of a proton, and they are held together by particles called gluons, and the gluons they carry what they call the strong nuclear force, and so we've been introduced to the electromagnetic force, which holds the electron to the proton in the atom, and now we see that inside the proton there are 3 quarks, an up and a down quark, and they're held together by particles called gluons, and they have fractional electrical charge, but if you look carefully, you add up plus 2/3 and minus 1/3, you'll see that adds up to +1 on the bottom left there. And although it's not important, the quarks have something else called color charge, and that color charge is adds up. Physicists, they just make up these names, but it adds up to what they call white. And I think artists consider red, green, and blue colors to add up to white. But that's not here nor there. We don't have to worry about that. Let's move on to slide number 12. And now here's what I was referring to earlier, how physics is a great field to get into, because it doesn't really, there's not much to memorize. This is really great. As I mentioned at the beginning, there are only matter particles and force particles. That's it. And then space-time. And particles are referred to as fermions, named after Enrico Fermi, the Italian physicist, who did a lot of work categorizing and classifying the matter particles. But if you look on the first column here, you'll see that there's two basic families of particles, quarks and leptons. And the quarks in the first family, there's only up quarks and down quarks. And then among the leptons in this first family, there's only the electron and the electron neutrino. And that's it. And here's the amazing thing, Ben. 99.9999% of all the matter in the universe consists of only these four basic particles. Isn't that amazing? And that's it. It turns out that the other two families, the second and third families there, the charm, the top, strange, bottom, muon, tauon, and so on, those particles are just higher energy versions of the first family, but they decay very, very quickly so that for our purposes here, we don't really have to worry about them. So if anybody who's in your audience who's interested in getting into physics, I highly recommend it. Just memorize these four particles and you're done. Matter particles. Okay, now let's go on to slide number 13. Again, with force particles, there's only four basic forces, and then there's the Higgs particle. I'll talk about that too. These are called bosons, and are named after, I'm not sure how to pronounce his name, but he's an Indian physicist who lived way back many years ago, but he worked with Einstein, and his name was Satyendra Bose, B-O-S-E, and he did a lot of work classifying the force particles and the forces of nature. But anyway, the exciting thing for those who want to get into physics there's only four basic forces to remember. The strong force, which is in the nucleus, the weak nuclear force, which is responsible for radioactive decay, electromagnetism, which we already saw holds the electron to the proton, and then gravity, which we all have to fight every day in the morning when we get out of bed, and especially before we've had our first cup of coffee. And so basically, the messenger particles that carry these forces are the gluons. There's 8 different types of gluons that carry the strong nuclear force. Then there's 3 particles, the W plus, W minus, and Z neutral, that carry the weak nuclear force. Electromagnetism is carried by the photon, and gravity is carried by a hypothetical particle which we've never seen, but hypothetically we believe it exists, called the graviton. And if anybody in the audience has memorized those things, they've taken one giant step toward getting their physics degree. So anyway, and then the Higgs particle, people have heard about this. That was in the news recently. The Higgs is actually a field that is believed to permeate all of space-time and is responsible for giving mass to the subatomic particles. And so that's it. There we've done the force particles. And we'll go on to slide number 14. And now here's where it gets interesting. The holy grail of modern physics is trying to unite the 4 fundamental forces of nature. It is believed at the very beginning of the universe that these 4 forces were combined together in a single force, which they refer to as the superforce. And there's good reason to believe this because there's certain symmetries among the forces that tell scientists, tell physicists, that probably at some earlier stage when the universe was younger, hotter, and under greater pressure, that these forces were probably just a single gigantic super force. And so let's take a look at slide number 15. Uh, so, on slide number 14, the previous slide, I want to emphasize that it's the holy grail of modern physics to try to theoretically and experimentally reunite those four fundamental forces of nature. And so that, keep that in the back of your mind. It's very, very important. So 15 billion years ago, here in slide number 15, how do you like that? I didn't notice that. and, um, but at the Big Bang, um, that's the universe began, and it was believed that all the forces were united. And immediately after the Big Bang, we're talking a couple of seconds, the Goot force, which stands for the Grand Unified Theory, and gravity broke out. Now you'll notice that the four forces that are boxed in the color red are the forces that we see today: strong electromagnetism, weak force, and gravity. But before that occurred, right after the Big Bang, as I mentioned, it broke up into the Goot force and the gravity force. But then the Goot force very quickly broke into the strong nuclear force and a force that theorists called the electroweak force. And then the electroweak force quickly broke into electromagnetism and the weak nuclear force. And so anyway, those forces that are boxed in red are exactly what we see today. But physicists have been very busy trying to reunite these forces. They've been trying to do experiments to get them theoretically and experimentally reunited. So, Ben, if we can go on to slide number 16. And now in slide number 16, it says unification theories, because physicists have actually been very successful in reuniting some of the forces. It was once thought, like in number 1 here, that the electric and magnetic forces were separate forces, but James Clerk Maxwell, the Scottish physicist, was able to explain theoretically how the electric force and the magnetic force are actually two components of a single force called electromagnetism, and in his Maxwell's laws. That's number 1 there. Number 2, incredibly, in the 70s, physicists were able to reunite in particle accelerators and particle accelerator experiments. They were able to reunite the electromagnetic force with the weak nuclear force, and they recreated the electroweak force, just for a couple of moments, but they were actually able to reproduce the force. So we now know that we're shooting in the right direction. We know that the theory is leading us in the right direction, and that's, by the way, very important. It's good to have confirmation of the theories. And now the third item here, they're trying to unite the strong nuclear force with the electroweak force to get back to the Goot force that we saw on the previous slide, and the Grand Unified Theory. And they've made theoretical progress there, but experimental progress, they're looking for something called proton decay. They haven't seen it, but if they do see it, it will confirm some of the theories they're working on here. So in any case, they have made some progress. But one thing you'll notice on the unification theories and that they've done so far, there's one force out of the four fundamental forces that's not included, and that's gravity. And the question is, how come only gravity is not included in these historical attempts at force unification? How come? Why not? And in the next slide, Ben, number 17, we're going to see why. Thank you. We're going to see why gravity is the odd man out. As incredible as it may seem, gravity is much, much weaker than the other forces in nature. Just to give you an example, the electromagnetic force is 10 to the 36 power times stronger than gravity. That's the number 1 followed by 36 zeros. And that is an absolute gigantic number. I think they might call it a Googleplex or something like that. You know, it's stunning, stronger than gravity. Or to put it differently, gravity is just incredibly weak compared to the other 3 fundamental forces of nature, and and that's really amazing. I mean, why is gravity so weak? And that's something in physics that's referred to as the hierarchy problem, this gigantic discrepancy between the gravity force and the non-gravity forces. And here, Ben, is where it's starting. This is where it's getting exciting as far as the UFO phenomenon goes. And here's where everybody's got to pay attention, because uh, this is the part, this is where solving the hierarchy problem, I believe, is going to be key to understanding the UFO technology. And we're going to see why. So we'll go to slide number 18. And in slide number 18, we're looking at the evolution of modern physics from 1900. Oops, I've got, actually it should be 2014. I've got to update this. Sorry. Okay, but um, but anyway, at the, you can see the this is chronological, starting from the top and going to the bottom. And the theories that are in the top of the slide here in the color black, and you can see the rough dates that are associated with these theories. These theories are basically the theories that have been confirmed through experiment from decades and decades of testing and careful analysis. And this is basically the foundation of modern physics: general relativity, quantum mechanics, classical mechanics, Newton's laws of motion, for example, and Maxwell's classical mechanics includes Maxwell's laws of electromagnetism. And general relativity, of course, describes gravity in terms of the geometry of space-time. And quantum mechanics describes the world of the very the particles at the subatomic level. And then all these theories are basically encapsulated in what is called the Standard Model. And people should remember that, the Standard Model. It is, I do mention it again later on in the show. So the Standard Model is basically what we definitely understand right now. And now nobody has to worry about memorizing all these theories. Basically, this is just a chronological list of how these theories have developed. But there's a couple of takeaways that everybody should pay attention to on this slide. And by the way, I did the theories after the Standard Model in alternating colors just to make them stand out there. But anyway, the important things to notice here are, if you look at these theories, grand unified, supersymmetry, 4D, supergravity, 5-dimensional Kaluza-Klein, 11D, supergravity, strings, superstrings, and brains, and extra dimension strong gravity theories. The takeaways that people want to remember from this slide are, if you look at these slides carefully, you'll notice something very interesting. Right up to the 1970s, 1980s, it was thought that we lived in a 4-dimensional universe, 3 dimensions of space and 1 of time. And that's what general relativity is based on. And then, but starting in the late 70s and 80s, they began to come up with theories that suggested that we might live in more than 4 dimensions. And that's where it gets very, very exciting, because this has a direct relation to, I believe, UFO technology. And you'll see that physicists are now talking about 5-dimensional universe and all the way up to 11 dimensions. And so remember that. That's very important. And then the other thing that's very important here is if you look toward the bottom here, you'll see strings and superstrings. String theory is a new theory that came out in the last several decades here. And it used to be thought that all the subatomic particles were dimensionless points. But starting in probably the 1970s, 80s, and they began playing with the idea that the subatomic particles might actually be these little wiggling strings. And that's also very critical to progress now being made in physics. So, Ben, if we can go to slide number 19. And now, modern physics is pointing toward a five-dimensional universe. And when I say five-dimensional, I mean five larger dimensions. Physicists actually think we live in an 11-dimensional universe. But if you take 11 minus 5, then you get the number 6. They think that 6 of the dimensions are curled up at every point in space-time, and those are referred to as Calabi-Yau spaces. But don't worry about that. For our purposes, we're just going to focus on the 5 larger dimensions that modern physics is pointing to. And it also looks like we may live on what they call a space-time membrane. You can think of like if you hold your hands up and have the palms facing each other. We live on a space-time membrane. Now, of course, they think that these space-time membranes are four-dimensional, that is 4 larger dimensions. And anyway, these two space-time membranes, they think there's at least one other one out there. They think they're floating in a larger 5-dimensional space. And the area between those space-time membranes is referred to as the bulk, B-U-L-K. So the space-time membrane that we live on is the universe that we see. You walk outside at night and you see those billions of stars up above you. You're looking at the space-time membrane that we live on. That's what scientists think. And anyway, the collection of theories that use these ideas are referred to as M theory. And if we can go to slide number 20, and this is a illustration of one of the most important theories in M theory. And what they think here is see, now if you look on the left side of that slide, that's they call it a D brain, which stands for Dirichlet brain, named after a German physicist, mathematician actually, who lived back 150 years ago, who came up with the kind of mathematics that they used to describe these space-time membranes. And anyway, the interesting thing is the standard model particles or strings, the force particles and the matter particles that make us up, all the atoms in our body, all the quarks, all the electrons, all the neutrons and protons, everything like that, they're all believed to be stuck on the membrane we live on. And physicists believe that, so the photon that carries the electromagnetic force is likewise stuck on this membrane that we live on, the one on the left side. And since we see with photons, that's how we look at things. Light bounces off an object and then it hits the retina in the back of our eyes, and that's how we are able to visualize and see things. But if the photons are stuck on the membrane we live on, then we can't see that bulk, that B-U-L-K, that new linear, that extra dimension that's out there, or that 5-dimensional space. We can't see into the bulk because the photons can't leave our space-time membrane. So all the subatomic particles, matter and force particles, are believed to be stuck on our membrane, except for one. And the one that is not stuck on our space-time membrane, as you can see on the bottom of the slide, is the graviton. And the graviton carries the gravity force. And this might help explain why gravity is so weak. If all the other force particles are stuck on our membrane, then those forces are going to be concentrated on the membrane that we live on. But if the graviton that carries the gravity force, if that force particle can travel into the extra dimensions here, the 5-dimensional bulk, what that means is that that could help explain why gravity is so weak, because so many of the gravitons are actually not on our membrane. And if we can go to the next slide, number 21. Well, and now everybody wants to pay close attention now, because we're closing in on how UFOs work, how I believe they work, and how they. And the first question we're going to answer is, how do they get to planet Earth from these great distances? Well, there's a theory out there called warp geometry. And the purpose of warp geometry, it addresses the hierarchy problem. It addresses some other problems too, but for our purposes, we're interested in the hierarchy problem. And this theory was developed by a Harvard physicist and another physicist from Johns Hopkins University down in Maryland, USA. And warp geometry solves one of the biggest problems in physics, which which we already looked at, the hierarchy problem. Why gravity is so much weaker than the other forces of nature. I got to get a drink of water here. But the important thing is that warp geometry solves the puzzle of why the gravity force is exponentially weaker than the other forces of nature, that is electromagnetism, the strong nuclear force, and the weak nuclear force. And Ben, if we can go to slide number 22. And here's where we're getting close to the explanation of the UFO technology. Warp geometry solves the weakness of gravity problem by postulating that the second space-time membrane, which is called the gravity brane, and that's the one that is, I showed in a couple slides back, that is believed to exist parallel to the space-time membrane that we live on, which is called weak membrane. A weak relates to the energy level of the membrane we live on. And it is believed that the gravity brane is warped in such a way that it attracts the overwhelming majority of gravitons in the larger 5-dimensional universe to its surface. And therefore, virtually all gravitons are in the bulk close to the gravity brane, which is why gravity is so weak in our weak membrane. Okay, now if we can go to slide number 23. And this illustration here shows what's going on. The membrane on the left side, which is referred to as the TeV brane, TeV stands for trillion electron volts. And that's basically the energy level of particles on our membrane. And it's also, as I mentioned, called the weak membrane. But this is the 4-dimensional world we live in on the left side. And on the right side, the membrane over there is referred to as the gravity brane, or the Planck membrane, named after the physicist Max Planck. And anyway, it's believed in the warp geometry theory, also referred to as RS1, that the graviton probability function, the number of graviton increases exponentially as you get deeper into the bulk, into this 5-dimensional bulk. And that means that the closer you get to the gravity brane, the more gravitons are going to be located there. And now everybody's got to pay attention. I know we've had to go through a lot of physics, but this is how UFOs work. This is how they get to planet Earth. The second I saw this warp geometry theory, I realized how UFOs could get to planet Earth. if they can get off the weak membrane over here on the left side and penetrate the 5-dimensional bulk, then general relativity tells us that um, when gravity gets strong, distances shrink. And that's the key to UFO technology, how they get to planet Earth. I believe what these UFOs are doing is they're going deep enough into the bulk where the distances between stars shrink to very manageable distances. And, um, and the other thing that does happen, of course, when gravity gets strong is time slows down. In the book, I explain how they overcome that factor too, because otherwise it would take you 10 trillion years to get someplace, even if you were able to shrink the distance. But in the book, I explain how they overcome that problem as well. But the key thing is that it looks like Mother Nature is providing a pathway to get to the stars. That's the amazing thing. We don't have to warp space-time ourselves. Mother Nature looks like it's doing it for us. Ben, if we can go to slide number 24. And slide number 24 basically reiterates what I was just talking about. The distances between stars shrink to very small distances, and that's what UFOs are doing. So if we can go to slide number 25, and this illustrates what's actually going on. Distance shrinks as you get deeper and deeper into the bulk. And by the way, when I went to Staples, I tried to get them to show the red curves becoming asymptotic, that is, coming together, and I just couldn't get them to do it. It's it's probably, I think it's done in another country, in India, and you have to work through like 2 or 3 layers of people, and I never quite got the message across. But anyway, yeah, people get the idea. And but that's it, and that's what's going on. And I think the UFOs are actually going into the bulk here, and that's how they get to other star systems. And if we can go to slide number 26. Here's a illustration showing a UFO leaving the weak membrane that we live on, and you can see the standard particles, and the UFO is in the circle here. And you'll notice that the UFO, the people in the UFO, just like us, are made of standard model particles. They're made of protons and neutrons, just like we are, and so they use these KK gravitons to pull themselves off the bulk. I'm sorry, off the weak membrane that we live on. And I was talking to Ben before I started doing this and doing the presentation, and I was talking to Ben about how a pilot in France back in 1986 observed a gigantic disc-shaped UFO, red in color, that it was 800 feet in diameter. It became partially transparent right in front of himself, the pilot, and his crew, and then became totally transparent. And I think that was an example of a UFO actually leaving the weak membrane that we live on and going into the bulk. And I think there's other stories where that's happened too. We can talk about that at some other time. But so it's definitely, there's a lot of indications that the UFOs are doing exactly this. And that's what's so exciting about this. The evidence is pointing toward the technology that they are using. And now if we can go to slide number 27. And in slide number 27, Ben, thank you, Ben. The UFOs here, this is an example of UFOs traveling in the bulk. And as I mentioned earlier, warp geometry, the theory of warp geometry, affects distance in the bulk versus the TeV brain. General relativity says that space contracts in the bulk. So warp geometry tells us that distances shrink in the bulk. It turns out that the nearest star system planet Earth is Alpha Centauri, which is 4.3 light years. That's about 25 trillion miles. So that's the number 25 times 10 to the 12, followed by 12 zeros. So absolutely humongous distance. Now, number 2 here, if the gravity force in the bulk increases by 16 orders of magnitude between the TeV brane and the Planck brane, which is what the theory of warp geometry proposes, then number 3, what that means is if we assume the UFO only goes in to the bulk, partway into the bulk, to the point where gravity is only 10 to the 12 orders, not 10 to the 16, but only 10 to the 12 orders of magnitude stronger than the TeV brane gravity, the gravity that we experience on planet Earth, that is equivalent to going into the bulk, the equivalent of only 1/10,000th of the maximum gravity strength in the bulk. Now, how much would that shrink the distance from 25 trillion miles to Alpha Centauri? How much would that shrink the distance if we were able to get a spaceship into the bulk? If we can go to slide number 28, thank you, Ben. It shrinks it down to just 25 miles. Isn't that stunning? And to put it in perspective, I could jump into my 1966 Ford Mustang, which I used to own, and I never sold. And it's a collector's item today. And I could have driven to Alpha Centauri in half an hour, depending on the speed limit in the 5-dimensional bulk and the traffic police. And so I hope it gives everybody how that tells us how these UFOs, how I think the UFOs are getting to planet Earth. They're simply going into the bulk, and they're taking advantage of the 5-dimensional bulk. And if we could go to slide number 29. So now the next question is, at the very beginning of this slideshow, we looked at 2 questions. The first is, how did they appear from other planets? And so we've answered that. It looks like Mother Nature provides a natural pathway for UFOs, whatever they call them, the craft to reach planet Earth. But the second question is, how are these UFOs able to perform inertia-defying acrobatics in our atmosphere? And here's how they do it in a single slide, virtually. I think what these UFOs are doing is they're creating something called these KK gravitons, Kaluza-Klein gravitons. These are predicted by M theory, if you remember way back at the beginning, that slide. And M theory, now it turns out the KK gravitons in turn will create micro black holes. So on our 4-dimensional membrane, the weak membrane that we live on, these micro black holes are expected to decay by emitting fermions, remember matter particles, scalar particles, which are Higgs bosons, and gauge bosons, which are the non-gravity force particles. But any graviton emissions from decaying MBH are expected to quickly disappear into the bulk as 5-dimensional gravitons. Now, that's important. You don't have to pay too much attention to that, but any physicist looking at this will know the meaning of that. What I mean by that is that these micro black holes do not emit gravitons onto the 4-dimensional membrane that we live on. So what that means is that once the 4-dimensional gravitons are absorbed by the micro black hole, because these micro black holes absorb 4-dimensional gravitons, and the reason I know that, I should give a little background here. Everybody's heard of black holes, and the reason they call them black holes is because even light cannot escape. Photons cannot escape from a black hole once they go beyond what is called the event horizon of a black hole. And And so one of the thoughts I had when I read about this is, uh, can um, can a black hole absorb gravitons? Because photons go at the speed of light, but gravitons also go at the speed of light. So I quickly went into a website called archive.org, arxiv.org, and I checked to see if anybody was writing papers on gravitons, four-dimensional gravitons being absorbed by a black hole or any black hole. And sure enough, I quickly found papers that talked exactly about that. And so I think that's what the UFOs are doing. They're absorbing, they're first creating collision gravitons, and then those KK gravitons in turn create micro black holes. And then the micro black holes absorb the four-dimensional gravitons, and it's those gravitons exchange particles that keep us pinned to the ground on planet Earth. And if we could eliminate those gravitons, we would float. and, and, and so isn't it interesting? And so essentially what happens is the graviton exchange between the Earth and the UFO does not occur. And it's very important to point out here, this is not anti-gravity. Instead, it is reducing the gravity force to near zero. And for physicists who might be watching the show, it's important to remember that conservation of energy is preserved, as we'll see in another slide. Ben, if we can go to slide number 30. Great, thank you. And here's an illustration of a UFO levitating above the surface of the Earth. And you can see the round circles there are the KK gravitons that are created by the UFO. And then the micro black holes are those black dots. And the micro black holes are absorbing four-dimensional gravitons from planet Earth. And that's what's allowing the UFO, as far as the Earth is concerned, the UFO could be as lightweight as a Frisbee. And I might add something here, a very important point. Anybody who's studied the UFO topic or subject over the years, there's one thing that every UFO researcher notices with all these UFO reports. And Ben, I'm sure you've heard about this. A lot of people report that when they see UFOs in close encounters, when they're relatively nearby, they'll notice that they're spinning, or at least part of the outer rim is spinning. And often they'll see where UFOs have landed on a field, they'll see a circular pattern in the grass. It's like a cyclone has hit it. And now it all comes together. You can see the logic of this. If they make these things as light as a Frisbee, then when you take a Frisbee and you toss it across the yard, what do you do when you toss it across the yard? You spin it. And the reason you spin it is because that's how you stabilize it. If you didn't do that, the Frisbee would, if you just tried to throw it without spinning it, it would just quickly wobble and fall to the ground. And that's exactly why UFOs are spinning. Because as far as the Earth's gravity is concerned, they're as lightweight as a Frisbee, and you've got to spin them to stabilize them. And that's further evidence that this is what they're doing. And it's not anti-gravity. It's basically reducing the effective gravitational force between the UFO and planet Earth. And so basically what they're doing, another way to look at it, is they're removing the mass of the UFO. They're demassing the UFO. So it's no longer a massive object. It becomes not massless. They do keep a little bit of weight because they still need action-reaction engines to move it around. And but they reduce the mass to a very low amount. Now if we go to slide number 31, and slide number 31 shows the absorption and emission of a hole. And the purpose of this is just the details showing how the UFO is normally exchanging gravitons with planet Earth, and the Earth is emitting gravitons too that go to the UFO. The UFO is emitting gravitons that go to the planet Earth. But when they shroud themselves in these micro black holes, what ends up happening is the gravitons never get to the UFO. They literally disappear from our space-time, and they end up in the energy of the four-dimensional black holes ends up being exiting into the five-dimensional bulk. And the important thing when you look at this slide is the conservation of energy law is preserved, because some of the energy goes into the five-dimensional bulk, and physicists do believe that we'll be able to measure any missing energy. When they see missing energy, they're going to be assuming at the Large Hadron Collider that particles have exited into the five-dimensional bulk. And so anyway, we don't have to go through the details here, but basically it's what I talked about in previous slides. And if we can go to the next slide, 32, and here, as I mentioned, I was going to explain how UFOs are able to do inertia-defying acrobatics. Here's how they do it. It's really basic. The equivalence principle of general relativity says inertial mass equals gravitational mass. Gravitational mass is weight. And number two, by eliminating or reducing that gravitational mass, UFOs eliminate or reduce inertial mass. And that's it. That's all there is to it. That's what they're doing, and that's what's so exciting. And I think, and it gets even more exciting than this because we can prove it. If we can go to slide number 33. Yeah, thank you, Ben. The Large Hadron Collider, the LHC, and UFO configurations. What's the connection between those two? Well, number one, the Large Hadron Collider, the LHC, is expected to produce gravitons and micro black holes. Number two, UFO configurations are typically disks, cylinders, or spheres. Even triangle UFOs have bright circles in each corner. So why do UFOs have this circular aspect to their shapes? The reason is because UFOs are particle accelerators. That's what they are. And that's why we've been observing these circular objects for so long. And I might add one other thing, just an interesting thought here. It's something that I was wondering, I thought about. UFOs really started to become very noticeable during World War II and after World War II, right after we developed nuclear energy and nuclear bombs and nuclear power and stuff. And I think there's a reason why I think there's probably a confederation of advanced alien civilizations, and I think they keep an eye on developing civilizations like ours. And what they look for is when a developing civilization begins to develop nuclear technology, because I believe once a civilization gets to build nuclear bombs and nuclear reactors and things like that, they are probably only 50 to maybe 100 years away from developing technology of creating KK gravitons and micro black holes, and most importantly, penetrating the bulk and going to their star systems. And that's why I think there's a heightened interest in our civilization right now, because they know we're pretty close to the point where we could travel to their civilizations. It could be a decade, it could be 20 years, 10 years, 15, 20, but we're going to get there. And and I think they want to introduce us to the Federation of Advanced Civilizations, but they don't want to give away their presence right away, because they probably have certain rules and regulations and protocols that we're going to have to abide by. And I believe one of them will be, we'll probably have to give up nuclear weapons. And as you may know, there's been a lot of reports of UFOs visiting sites where they have nuclear weapons and even shutting down nuclear missile sites. you may have heard of, yeah, I think it was North Dakota in the United States here, where UFOs actually shut down about 20 missile silos. And they did the same kind of thing in Russia. And I think there's a very good reason for doing this. I think they're watching us carefully. And when we develop the technology to get into the bulk, they're going to come and introduce us to the Federation. And they might actually, before they introduce us, they might basically shut down all our nuclear weapons. You know, and for the simple reason they do not want, once we have the ability to travel to their stars, they don't want us bringing nuclear weapons to their planets. And I think it's as simple as that. And if we go to slide number 34, and oh, now the next two slides, Ben, thank you, Ben, for turning that, are related. The first of these two slides is the effects of UFOs in close encounters, and the second of the two is the expected effects of UFOs in close encounters if these UFOs are using the technology that we here on planet Earth are just on the cusp of understanding ourselves, the work that's going on at the Large Hadron Collider in Geneva, Switzerland. Okay, so let's look at the known effects of UFOs in close encounters. For one thing, there's evidence of strong magnetic fields. Pilots report compasses spinning wildly when UFOs get close. And as I mentioned earlier in the presentation, there's indications of, number 2 here, indications of strong attractive gravity field, stopping or slowing of clocks, objects and masses of water being lifted toward the bottom surface of UFOs, and light beams being bent toward UFOs. Number 3, there's certain types of radiation detected near UFOs. Paul Hill, he was a NASA scientist and an early UFO investigator, but he noted evidence of gamma rays, X-rays, and higher frequency light emissions in the visible spectrum from UFOs. So that's very important. And then number 4, observation of UFOs becoming partially or totally transparent. That's extremely interesting characteristic of UFOs, but it's been a number of times. Now, so keep in mind these 4 characteristics that they've noticed: magnetic fields, strong magnetic fields, attractive gravity field, certain types of radiation, gamma rays, etc., and UFOs becoming partially or totally transparent. So what would be the expected effects of UFOs in close encounters? And Paul, Ben, if we can go to slide number 35. Great, thank you. The expected effects from proposed UFO technology. Well, son of a gun, look at this. Number 1, micro black holes, which is part of the technology I was suggesting that they are using. It turns out that micro black holes create strong magnetic fields, and that would explain the observation of strong magnetic fields. Okay, that's incredibly interesting. This is excellent circumstantial evidence. Number 2, KK gravitons generate a strong attractive gravity field. That would explain why they have this strong attractive gravity field that Ron Sullivan, for example, noticed with his headlight beams bending toward the UFO. And the KK gravitons, most of them will have mass, and so the strong attractive gravity field will be of relatively short range. That's important to remember or to point out. And number 3, the micro black holes will decay into Hawking radiation, and it turns out that Hawking radiation includes gamma rays, X-rays, which is exactly what NASA scientist Paul Hill, engineer, saw. He detected, he took around Geiger counters and he detected gamma rays and X-rays coming from UFOs. And sure enough, that's exactly what I'd expect if they are using micro black holes, which decay into Hawking radiation. And number 4, as I mentioned earlier, an object on our weak membrane penetrating into the bulk, the 5-dimensional bulk, will be seen to fade disappear from our weak brain space-time. And again, that's exactly what we're seeing. So everything is starting, all this circumstantial evidence is pointing toward the UFOs using technology that we are literally within a few years, maybe within 10 years, of understanding ourselves. And Ben, if we can go to slide number 36. Okay, thank you. Can we prove? Yes, we can. And this is exciting. Number one, the Large Hadron Collider will give evidence confirming or disproving M theory and warp geometry. So we need to pay attention to what's going on at the Large Hadron Collider in Geneva, Switzerland. And number two, more UFO data needs to be acquired that can potentially the proposed UFO technology. In particular, a full spectrum analysis of brightly lit UFOs would provide critical data on how they function. And we need, the spectrum must include things, the electromagnetic radiation emissions outside of the visible spectrum as well as the visible spectrum. That's key. That's absolutely key. And Ben, if we can go to slide 37. This slide is just, it's probably kind of hard for the audience to read, but it basically shows the electromagnetic spectrum. And if you can look toward the middle right side of the slide, you can see that the visible spectrum, that little rainbow there, is tiny compared to the total electromagnetic spectrum. So if we're going to figure out the emissions that that these UFOs give off, we're going to have to get equipment that will pick up gamma rays and X-rays, ultraviolet, infrared, microwaves, and radio waves, as well as the visible spectrum. So I just want to mention that in passing. Slide number 38. And this is just an illustration of how Hawking radiation works. We don't really have to go through that. We can go to 39, slide number 39. The Hawking radiation curve, if we can gather this data, will look something like this. On the y-axis will be the intensity of the radiation, and on the x-axis will be the wavelength of the radiation, and it should look something like a normal curve like this. This is a slide I got from the internet. It's not Hawking radiation, but it is just an example of what it might look like. If we go to slide number 40, and now these next two slides here are very interesting. So the question is, where do we go from here? And I'll tell you what we need to do. We need help in obtaining spectrographic data. Number one, we need volunteers with access to expertise in spectrographic equipment or willing to learn. And unfortunately, the equipment can be expensive. It can be 10, 20, 30,000 bucks. So I'm afraid we're going to have to, if have to people from universities to help us. I'm afraid the UFO community simply doesn't have any money. And it's horrendous. And two here, we need the electromagnetic data in both the invisible and visible optical spectrum, as I mentioned. Number three, in the invisible spectrum, we need to put particular focus on gamma rays, and I'll explain why in a second. Number four, we need both frequency and intensity for the electromagnetic data, which means we have to know how far away these objects are from our equipment in order to figure out the intensity. And number five, while we can't predict the appearance of UFOs, we can't do that, but they are often seen multiple times in the same geographic area, such as the Phoenix Lights in Phoenix, Arizona, the Hudson Valley, New York sightings, or the Belgian triangles. And I'm sure many in the audience are familiar with those major sightings UFOs. So, in other words, if we do get into uh, a like this UFO particular area of planet Earth, they often stay in that area for weeks and months at a time. So that's an opportunity to get our equipment once we figure out how to buy it or borrow it. um, Once we get to that, we can rush the equipment to that area and hopefully capture the data we need. And then we have one more slide with writing on it, but this is a very important one, and everybody needs to pay close attention to this slide. These are important notes on the spectrographic data that we're seeking to get. Number one, we are looking for the unique spectrum of Hawking radiation. Number two, Hawking radiation is a byproduct of micro black hole decay. Actually, any black hole decay, but we're going to be looking for micro black hole decay. And micro black hole decay terminates in a burst of gamma rays. That's why detecting those gamma rays is very important. It's telling something about the technology that these craft are using. And number three, and this is very exciting, listen to this. No one has ever seen Hawking radiation, although physicists are confident it is real. I know this sounds pretty far-fetched, but we UFO investigators, if we're able to gather this spectrographic data and prove that the UFOs are emitting Hawking radiation, we could actually help Dr. Stephen Hawking get a Nobel Prize, because once this is no joke, once Hawking radiation is discovered, then it will prove his theory to be correct, because at this stage it's still a theory, and wouldn't you love to help Dr. Hawking get a Nobel Prize? Wouldn't that be great? And by the way, if we UFO researchers discover Hawking radiation from UFOs, I absolutely guarantee the scientific community is going to pay attention to what we're doing, and they're going to pay attention to the UFO phenomenon for sure. Then you're going to see massive government spending because something is going on here. Number four here, detection of Hawking radiation would virtually confirm that UFOs are using M theory, warp geometry, KK gravitons, and MBH microblack holes in their technology. And number five, there already is evidence of this in strong local attractive gravity fields, that's the KK gravitons, and the detection of gamma rays, that's the microblack holes, by NASA scientist Paul Hill in the 1970s in an informal study and other evidence. And that concludes the text on the slides. And I just have a few pictures I'd like to show, Ben. If we can go to slide number 42. Thank you. And that's just a picture that also appears on the cover of my book. If we can go to slide number 43, that's a triangle UFO. This one was taken in Salem, Massachusetts, on the east coast of the United States in 1952. And you can see the bright glow of these formation of UFOs. And I believe if somebody back then had a spectral equipment and had captured the data, he would have captured Hawking radiation, although in 1952 they didn't know what Hawking radiation was. But if they kept that data, in a decade or two, they would have figured it out. If we can go to slide number 44. Okay, thank you. And this was taken in Belgium in 1955. And notice how the object is lit up on the bottom only, and very likely because the microblack hole shroud around a UFO in some ways would prevent them from observing the outside air around them. So what they're probably doing here is the top part of the UFO is where the UFO astronauts are, for lack of a term to call them that. And so this allows them to see all around themselves, but the graviton sink is what I refer to it as, where they absorb gravity. It's just on the bottom where it's needed, and then on the top part of the UFO they can observe the Earth below and stuff. So if we could go to slide number 45. Thank you, Ben. And this was a photo taken by a Canadian Royal Canadian Air Force pilot. Again, I think it was back in the 50s. And he observed this a disc-shaped metallic-looking object floating in the clouds, and it was bright, shining quite. What's important about a photograph like this? It's taken by an incredible person, a pilot, and these guys know what's up in the sky. So that's significant. Uh, Ben, if we slide number 46, and here's another slide or photo taken by Air Force personnel. This is by the United States Air Force, and this looks the thing that was following this craft. I forget it might be an RB-47 or something like that. I'm not sure what. No, I'm not sure what this is, but I should know. I can't remember. But this is a smaller UFO, but again, it's circular in shape. That's how the crew described it. And I believe it's nothing more than a probe that they send down. They don't like to risk the larger disk near our aircraft, and because they can interfere with our electronics, things like that. So they send these probes just to observe them closely. But again, it's a highly credible photo. It was taken by the United States Air Force. And by the way, it was taken in 1957 at Edwards Air Force Base, which is interesting in itself for two reasons. Number one, it shows the UFO's interest in our military. And number two, 1957 was a gigantic UFO wave year, as Ben and many of the people in the audience, I'm sure, are aware of. And Ben, if we go to slide number 47, and here is yet another photo taken from a gun sight camera by a French fighter pilot in the 50s. Unfortunately, two dates are shown different, but somebody told me I think it was 1954. But anyway, again, you see the typical disc shape, flatter on the bottom, the hump on the top, and this projection on the top, whatever that is. But again, it's a credible sighting, and it's good evidence. It's only in the visible spectrum, but it's something of value. If we can go to slide number 48. This is a cutaway of the Large Hadron Collider over in Geneva, Switzerland. And the actual circular track where they collide subatomic particles together at almost the speed of light. This thing is around 26, 27 miles in circumference. So this is gigantic, And they have 4 different locations here where they smash the particles together, where they have these detectors. You can see the Atlas detector, the Alice detector, the CMS, and the LHCb. And that's where they actually do the experiments. Now, if we can go to the next slide, Ben. This is a photo taken inside the tunnel of the Large Hadron Collider. That gives you an idea of how big this baby is. I mean, it's one big thing, And if we're standing next to it, you'd just be slightly taller than the steel tube that they have here. And if we can go to slide number 50, and this slide is very, very interesting. This slide is very interesting because if you look at the bottom center of the slide, you'll see a worker down there, one of the LHC workers, and you can see how small he is compared to the detector that he's working on. This is one of the 4 detectors, and that gives you an idea how gigantic this whole project is. I mean, this is billions upon billions of dollars. And 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 there's just one more important slide I want to show. Things I want to mention is that the before you show the next slide, I don't know how many people are aware of this, but the Large Hadron Collider crashed about 2 years ago, and they were and what happened is the whole thing came down. They had to bring it down for almost to repair it, and they were trying to figure out what happened, and things they found was in the sensitive electronics they found bubble gum. and and so anyway, they were trying to figure out who was responsible for knocking this thing down, and in the next slide we'll see. And if you look at the little guy with two thumbs up, we think he was the mastermind. and anyway, I'm only kidding, of course, but these are kids on a school trip, the Large Hadron Collider, and I thought I'd add that in for a little humor. And that basically ends the slideshow, and that's it. And go back, Ben, to the where I can see you, and I actually could see you all along in the upper right. And but anyway, what did you think?
Okay, folks, I'm sure you've really absorbed the engaging presentation that Robert has been kind enough to share with us today, and I think that you would agree that a lot of what he's talking about really does make a lot of common sense. And I think that moving forward, we really do have to look very carefully at these ideas that he has proposed. Now, I would really encourage all of you, if you've had your appetites whetted by today's presentation, to get a hold of Robert's book, which is called Solving the UFO Enigma: How Modern Physics is Revealing the Technology of UFOs. And it's a very, very engaging read, and it will explain in a lot more detail some more of the concepts that we've actually explored in a brief time frame today. So I do encourage you to try and find that book, because it is it's a very good read. So yeah, so thanks again, Robert.
Oh, Ben, thank you very much for having me on your show there.
Yeah, no, it's been really, really good. And look, I just want to say that like a lot of people, probably aren't that familiar with the concepts of physics, but I think you've explained it in a very, very understandable way. Taken a lot of the mystery or the mathematics out of it, which certainly a lot of people can't understand. So yeah, I think the way that you've presented it is very, very, very good.
Oh, thank you, Ben. And one of the things, Ben, that I really want to emphasize in the presentation there is that it's so it would be so helpful if we can get that spectrographic data. That's kind of like that's my holy grail. I know.
Yeah.
I don't see. I'm kind of hoping that as I do this presentation around the United States and around the world, and in England too. I did it in the United Kingdom. Yeah. I'm hoping to attract the attention of scientists and physicists or people that are maybe know somebody who has access to and expertise in the use of spectrographic equipment, because unfortunately, as I mentioned during the slide presentation, the equipment can be rather expensive, and so I do see this as a fairly big project, but I'm hoping it can be done in many different countries, Australia, in Europe, in the United States, and multiple locations in each area. So anyway, that's kind of my plea that I'm putting out there. I'm sort of hoping that if people listening to this are either have spectrographic equipment, if they have access to it, boy, we could really use their help, knows somebody who has the equipment, if they could show them the presentation, maybe that would get their interest, something like that.
Absolutely, absolutely. So I'd just like to sort of also, I suppose, begin the conversation just perhaps talking a bit about the book. What prompted you to write the book in the first place? And if you could just perhaps briefly explain, the process and the time frame that involved for you to put together, what is, quite a complex presentation.
Thank you, Ben. You know what happened? Way back in the 1950s, I was only in 1957 actually. I was only 12 years old. Now everybody can calculate my age. But anyway, in Teaneck, New Jersey, which is northern New Jersey, a couple miles west of New York City, and anyway, I come from a family of scientists and engineers. My dad was a research chemist and a graduate of MIT, and his father, my grandfather, was a mechanical engineer. Many of my siblings, my brothers and sisters, are in technical fields as well, and I have degrees in aerospace engineering, mathematics, and I have an MBA on top of all that. But anyway, I've always loved science. But what happened in 1957, even though I was only 12 years old, I happened to be out in our front yard. It was only about 5 o'clock in the afternoon. It was early November 1957. And I looked up in the sky, like a kid that age, you're always looking for airplanes and stuff. And it was a clear blue sky. I'll never forget it. And I saw this cylindrical shaped object that was probably 5,000 or 6,000 feet up, and it looked pretty much like a cigarette. And but it was metallic looking and gold in color. And directly behind it, maybe one length of the cylinder, was a round object that was no wider than the narrow width of the cylinder. And I thought that might be a sphere, like a ball of some type. And being a kid, just 12 years old, my first thought was, my God, this is Sputnik. Sputnik satellite had just gone up. And but I couldn't figure out, why the satellite was behind the rocket, or for that matter, why the rocket was still in orbit. It falls back down. And then I remembered reading in the paper that Sputnik was only the size of a basketball or something, or a beach ball, and I knew that it was about 100 miles up, and I knew there was no way under the sun that I could have seen Sputnik. No way. And I knew if I had put a beach ball a mile down the street, I'd have trouble seeing it. So I knew 100 miles was no way. And at that point, I knew this was really unusual. So I ran inside to try to get some of my brothers and sisters, and I managed to drag out 2 of my brothers. And as the thing was going over the trees heading toward New York City, they did see it. But that's what kind of got me into the UFO field, or literally at that age. And it was a couple years later, when maybe I was 15 or 16, I began reading books on it, just casually, because I was pretty busy and stuff. But then I came to the realization there was something going on, that these things were real. I mean, anybody who's ever seen these things in a good encounter, or not an encounter, but a good sighting, you know virtually right away that this has got to be some kind of extraterrestrial craft of some type. And I knew it, and that I've been on a lifelong quest to figure it out. Of course, I had to I was supporting a family for many decades, and still, and of course I had to work like everybody else, and so I didn't have too much time to devote to UFO research. But because I love science, I come from a family of scientists and engineers. I continued to read physics and science all through these years, and I retired a couple years ago, and just before I retired, maybe 2 years before I retired, I had much more time on my hands, and I began writing the book, because by the 21st century, I realized what was going on in modern physics looked like it was pointing toward a very likely explanation of UFO technology, and that's what got me excited. And I knew that if we can get the spectrographic data, I knew we could figure out how we could confirm if they are using technology that we are literally on the cusp of unraveling ourselves. And that's pretty much how it all got going, and how I got into this.
Oh, fantastic. And I just was also really interested to find out what reaction you've had to the book from, well, certainly from three places, from, say, the public, the UFO community, and even more importantly, the scholars out there in the universities.
Okay, that's a good question. I've talked to, well, first I want to put a little caveat out there. No working physicist or scientist will touch the UFO subject with a 10-foot pole, not go near it. And the reason is unfortunately, it's been ridiculed and discredited over the years, and even more unfortunately, there are admittedly a number of people out there, hopefully not too many, but who fabricate UFO sightings, and that's a persistent problem in the study of UFOs. You have to be extremely careful with the witnesses, because it's kind of, people enjoy having fun, and people like to make up stories, and so you got to be careful. That's why I tend to focus on military sightings and multiple witness sightings where there are many witnesses, especially those witnesses who don't know each other and are at different locations. Those are the best type of sightings. But if you get somebody who's sitting on the corner with a paper bag and a bottle in it and they're drinking, and those, a little more cautious about, So with that caveat, I'll say this, that I did get a physicist to read the book, and he said, the guy that did the, he wrote up a little blurb on the back of the book, and he thought, there's something, it's potentially possible that they are using this kind of technology, and privately, a few physicists have told me privately, when I go to some of these UFO conferences, and they happen to have a couple of scientists there, they of course, I cannot use their names, I can't put them on record, but they've told they were fascinated with the idea that I had, and these are retired people. I did speak at a university. I was at Worcester Polytechnic University Institute over in Worcester, Massachusetts, and I had a whole bunch of engineers and scientists there, and they were fascinated with what I was talking about. But they were all retired. That's the only kind of people that we dare come take a look at this topic. But at least I'm getting somebody, but they told me that they said, if you can get this spectrographic data and you see Hawking radiation, you're onto something. That's what they told me. Absolutely. That if we can just get that data. And so and then as far as the UFO community, their reaction has been very positive. I've been invited to a number of conferences. I'll be going to the International UFO Congress down in Scottsdale, Arizona. I should know. I'm in a week and a half, and I better know where I'm going. But anyway, that's a gigantic conference. They expect up to 2,000 people there, so I'm excited about that. I'm also excited because there's going to be major media there, television and radio and print. So I'm kind of hoping that I might just attract the attention of some working scientists and physicists who might be willing to take a risk and take a look at this, and help us gather the spectrographic data. So I'm kind of hoping on that. So anyway, the reaction of the UFO community has been very positive, very supportive. But again, as I mentioned earlier, the big problem is we have no money.
Yeah, very much can relate to that. No, that's really good. Yeah, because I'm sure anyone who's watched today's presentation would see that it is very logical, and now we have to really get down to the business of detecting the Hawking radiation, which leads me on to the next thing I'd like to have a brief discussion on, is how do we get the on-the-ground effort going in a coordinated kind of a way?
That's a good question. And unfortunately it's going to take money, and that's one of the key things. But the other very important factor is we have to bring in legitimate scientists. Unfortunately, this is one of those situations where if it's only people that are connected to the UFO field that are involved, the mainstream scientific community is not likely to believe us. They're not likely to take a look at the data. So I'm afraid what we have to do, and this is where the money part is probably important, we're probably going to have to hire people, and we're going to hire people who are skeptics, or at least, who are from the scientific community, and I certainly promise them anonymity. I don't want them, I don't want the word to get out that they're helping us, because that could harm their careers. It's kind of like touching the third rail, it could definitely be damaging to your career, and so I think one of the thoughts I had, I know I'm kind of rambling here, but one of the thoughts I had is to do one of these crowdfunding things like Kickstarter, and that could provide the money that could be used to hire the experts in the field to help us gather the data. That's one possibility. I'm not too keen on that for the reason that unfortunately it would take an awful lot of my time and energy just to organize that, and I'd rather focus just on the science part rather than the management part of organizing a bunch of scientists and engineers, and not only in my country in the United States but all over the world, because I'd like to make it, like you said, I'd like it to be coordinated. So I'm sort of thinking of that. It's on the back of my mind, but I'm the other possibility. I'm praying, and I could win the lottery. And I'm not kidding about that. I actually play the lottery, and really got lucky and hit 20 or 30 million or something like that, and then I could do it on my own, and I wouldn't have to worry about managing a Kickstarter campaign. You've probably heard of Kickstarters. It's one of those crowdfunding things, you've crowdfunding, I guess, where they go out and it's an I don't know if it's in other parts of the world, but what happens is people come up with a product, like they came out with 3-dimensional printers, and they need funding for it, and they go to this organization in New York City where these people, they put it out on a website, and millions of people look at this website, and then if they want to help the people that are doing this project, they don't get any monetary compensation, but what they do get, they might get a visit to the plant where they're building the 3-dimensional printers. I think you've heard of 3D printing, and and or they might get a brochure, or they might, if the people have published a book, they might get a copy of the book, or they might get a T-shirt with the name of the company, that kind of stuff. And so the idea behind it is it gives people a chance to help somebody who's working on a project to get the project off the ground, and then say they were part of history. And of course, if we're right about the UFOs using technology that we're just on the cusp of developing ourselves, this would be a spectacular thing to be involved in, because you would truly be part of history. I mean, this could literally change. This would probably be the biggest change in technology that we've had in probably 1,000 years. It would just be stunning if they are using this technology, which I think they are. But anyway, that's another possibility if we can get the crowdfunding, if I win the lottery, and then maybe maybe there might be a few very wealthy high-tech people, like one of them, Steve Ballmer, I think that's his name, from Microsoft. I think he funded some UFO projects, and then there's another guy, his name escapes me, I can't remember, Bigelow, Robert Bigelow. He was a real estate magnate, and he's down in Arizona, Nevada, or someplace, and I know he's funded some UFO projects too. So that's another possibility. It's probably unlikely, but maybe lightning will strike, we'll get lucky.
Do you feel it's likely that with the 50 years of UFO research that has already occurred since say 1947 or so, do you think it's possible that within the research the UFO community has done, that some of the evidence is already there, that we actually have detected some of these things, or are you saying that we just don't have the technology at any point previous to this, that we could already see some of this evidence actually been recorded when MUFON, for example, have gone out and done an on-site investigation, and they've used their the detectors and things out there? Is there anything there now that that is concrete enough, do you think, or is much more work required?
Okay, very good, Ben. That's a great question, a really good question. Actually, there's no question in my mind that we can get this data, but I doubt very much that anybody has ever gotten the complete data that we need.
Yeah.
And the reason I say that is because I've been following the topic of UFOs for, yikes, more than half a century. I know what's going on in the UFO field, and I know that. There's one other thing I do want to mention. There is a guy by the name of Doug Trumbull. You may have heard of him.
Yes.
You've heard of him?
Yes.
He's the special effects guy for Steven Spielberg in Close Encounters of the Third Kind, that movie. He also did 2001: A Space Odyssey, and he's done a bunch of major Hollywood films. So this guy is big. He knows special effects, he knows photography, he knows cameras, and that sort of thing. Incredibly, Doug Trumbull is interested in the UFO phenomenon, but he's a very serious researcher. He has absolutely no interest in abductions or people having mental telepathy with these things or any of that stuff, which I know in your conversation with Martin Willis, he was skeptical of it. And I have to say, Ben, I'm sorry to tell you this, but I'm skeptical too.
Well, personally, I think it's another aspect of the phenomenon, and I think that from a purely a straight up and down point of view, the only way that we can really approach it is to look at the actual physical evidence.
Yep, I agree. I could be proved wrong. Maybe somebody has taken a ride on a flying saucer. I don't know. But I don't think so. I kind of have my doubts. But that's my opinion. But again, if you end up, you know, if somebody claims they've been on a UFO, and they come back and they have an artifact, and it's made of a metal alloy that we've never produced on Earth, you know, that would open up the case. That would be spectacular, you know. But but again, I'm not sure that we'll find that. But going back to Doug Trumbull, Ben, Doug Trumbull, he has actually he's got I forget the name of his site, but if you go into one of his sites, you can maybe just look it up on the internet. He's got a little video that he does on. He's taken these ex-military Humvees. You know, they look like a oversized Jeep.
Yep.
And what he's done, he's refitted them. He's made it so that the roof on the vehicle opens up, and of course these are four-wheel drive, all-terrain vehicles, and very stable platforms, good solid suspension. And what he's putting in is he's putting in equipment for tracking UFOs, and I'll send you the website that he's on, where you can actually take a look at the video that he put together. It's really good, and I'd like you to, if you get a chance, to show it to the people there in Australia. But anyway, Doug doesn't really want to work directly with UFO people. I tried to contact him, but he's kind of, just like I said about physicists and scientists, that touching the UFO topic is like touching the third rail, you know, and it's career limiting, you know.
I understand. I definitely could imagine that, and that's why we see the reluctance from the education community, isn't it?
Exactly. And so it's unfortunate, but that's the way it is. However, I did check out from his website. I was able to figure out the type of electromagnetic emissions that he is picking up, that he's trying to gather, and unfortunately it doesn't include X-rays and gamma rays and microwaves and stuff like that. And now he may be changing that in the future, but I don't think so. He's mostly looking at the optical spectrum, which just simply isn't enough. We need the entire spectrum, as I talk about in the presentation there.
Yes.
So I did want to mention Doug Trumbull, because I do want to show that there are people who have some money. He did write. Oh, by the way, Doug had the same problem we have. He ran out of funding.
That's a big problem.
Oh, I tell you, it's you know, like the story of our field, you know.
It is.
So, but anyway, at least he's very professional about it. He really knows cameras. He's really got incredibly good equipment. The optical equipment that he does have, which I'll send you the link to his site. The optical equipment he does have, Ben, is first class. It's really, really good, and I really like your people in Australia to see that video, because it'll give you an idea of what I'm trying to do. Except I want to get the entire spectrum, including gamma rays, X-rays, ultraviolet, microwaves, infrared, and so on. You know, so I think I answered the question.
You did, and we won't go for too much longer in this session, but I did just want to touch on a couple of points from the presentation. Certainly from a layman's perspective, which I think I can represent lay people across Australia and across the world. So these craft are penetrating the bulk. I understand that, and it's enabling them to cross vast distances. I just wanted to touch on the crafts themselves. What materials would they have to be likely to be made of to withstand any pressures, or how intense that actual process would be? Can you give us any feedback on that at all, Robert?
Yes. Oh, yep. That's another very good question. I thought about that too, because and I believe I know the answer. When they're in the five-dimensional bulk, when they go in there, they're dealing with tremendous gravitational forces, and I believe what they're doing is very, very simple. I mean, once you understand the string theory is not simple. But once you get to that point and you understand how it works, from that point on, it's pretty basic application of the ideas that our scientists are developing. But anyway, here's how they do it. I believe what they do is they surround the UFO in a shroud of micro black holes, and that totally protects it from the five-dimensional bulk. And it's as simple as that.
Okay.
And that's one of the reasons why when they see these UFOs, like some of the pictures that I showed during the presentation, you saw the glowing UFO. The reason it's glowing is because the micro black hole shroud around the UFO is activated. So if I'll show you what that means. If, let's say, they went over a missile site which had nuclear tipped missiles, anti-aircraft missiles, and the people decided to try to shoot down the UFO, they could shoot this nuclear tipped missile at the UFO. It would actually detonate right at the micro black hole shroud. The people inside of the UFO could be sitting having their afternoon tea, and they wouldn't thing.
Well, that's amazing, because I was very much, I do think a lot about what UFOs are actually made of, and our aircraft are made of aluminium, titanium, and all these other exotic alloys that they're coming up with now. So what you're suggesting is that the actual shroud around that encases the craft is protecting it, so therefore it doesn't necessarily have to be made of some exotic material. Exactly. Yeah, I forgot to mention the materials themselves. It's not that critical. They can make it aluminum. They can make it out of balsa wood. Yeah, right. Yeah.
Really matter. Well, actually, there may be some other problems. But I was going to say something about the as far as the nuclear missile hitting next to the UFO. The reason the blast from the nuclear missile would have no impact on the UFO is because all the energy from that nuclear missile that's directed toward the UFO would actually be diverted into the bulk, and would just disappear from our or to be blasted back into our own atmosphere. But the UFO itself would feel nothing. You and I, if we were inside the UFO, we could be putting our sugar cube in the tea.
I only have a couple more points for you that I'd like to touch on. How do you decide that you want to go from Earth to Alpha Centauri, get into the bulk, and navigate to that particular region? How do we navigate to particular locations, when to me it would almost seem like you could end up anywhere once you were actually into the bulk? How can you can't plot going from New York to Boston in the similar way when you want to go from Earth to Alpha Centauri. How do they navigate through this dimension?
Ben, that's another absolutely great question. When I go and do talks at different conferences, I always pray that people will ask these kind of questions, because I love them,
Yeah.
But they usually don't. They usually ask other things that aren't as much fun.
Yep.
But that's a good question. I believe I believe that once we get into the bulk, we are going to be able to. I think when you're inside the bulk, we'll have sensing equipment, and I believe that all the other stars that are in the universe, the galaxies and stuff like that, will leave an imprint in the bulk. In other words, at least a gravitational imprint, and so that we'll be able to detect them by either gravitational waves or gravitons themselves. So in other words, when you're inside the bulk, now it may not be, it may not be like you're not going to see land there. That's not what you're going to see. It's going to be just basically space, but it's going to be kind of what it actually looks like. In fact, you won't be able to see it because we'll need other instruments to move around in there. It's kind of like going into the ocean. When you're deep down in the ocean, you can't really see around you. It's black. but you know you're in the water, and you can tell by the pressure how deep you are, because the pressure gets greater the deeper you are. And then and so I believe it'll be something like that. What we'll see is like spots. We'll have like some kind of gravity map or something like that, that we'll see a concentration of gravity here, a concentration there, a concentration here, and we'll be able to identify or to correlate that concentration of gravity with Alpha Centauri or with the Andromeda Galaxy or things like that. And that's what we're going to see. And then you just make a beeline for that target and you're on your way. So I think that's what it's going to be. And it's going to be a bit tricky because it's going to be 5-dimensional. So it'll be 4 spatial dimensions and 1 of time. So it's going to require some new physics to navigate the bulk, but I'm positive we'll figure it out. And by the way, the first time we enter the bulk, it won't be with human beings, and it'll be with they'll send probes into the bulk, and then hopefully the probe will come back, you know. But if it does, then we know we need to do more adjustments, and then we'll finally figure out how to get in there.
What perils do you see with going into the bulk? Because obviously it would be a completely new world that we would be exploring. Would it be possible to break down in the bulk? Would it be possible that when you come out the other side you smash into a planet that you didn't see on the gravity map, or you hit a comet or an asteroid? Are they realities, do you think?
Yeah, that's another good question. I totally agree. There's going to be great danger in the bulk, just as there's great danger in outer space. When we go into outer space, we have to worry about getting hit by a meteorite or something like that. However, if you surround your UFO with micro black holes, like at the Shroud, then you're actually quite safe, because as long as the shroud of micro black holes around your UFO is strong enough, it'll absorb anything that comes at you. I mean, it could be the moon. I mean, I wouldn't want to destroy our moon, but
no, not at all, not at all. So yeah, okay, because yeah, I think about these things a lot. You know, how they travel here. You know, what perils that they must actually encounter along the way. Now, just another question I've got also is areas on the Earth, such as, for example, the Bermuda Triangle, or where there's greater areas of magnetic effect. Do you see that is there anything from that side of coming at it from that way, that there might be areas on the Earth where it actually is better or easier to enter the bulk, given particular geographic locations? Like, we launch space shuttles from Florida for a reason. Would there be anything like that, do you think, or would this type of what we're talking about here means you could actually do it pretty much anywhere?
Yep. The last thing you said is what I think is what's happening. Yep. They can come anywhere, and it's interesting because to give a good example of that, a airline pilot, I think he was in a what the heck was it? One of these big jets, like a DC-10 or something like that. But he was up near Chicago, and he I can't remember the name of the pilot. It might have been Schultz, like or something like that. But he was he and his crew observed a sudden activity in the sky about 2 miles away from their plane, and they said it was like, this is what they said, Ben. They said it looked like the sky was splitting open. And they said all of a sudden an object appeared, and I think that's exactly what's going on. They can come anywhere they want, and they could even come inside the planet Earth, although they would have to gobble up rocks and stuff like that to get up to the surface. But because the micro black holes will swallow anything. I mean, a rock is no big deal. You know, they'll just suck it up and it'll disappear. In fact, a good example of that is down in Florida. Some people were on a beach down there. A UFO came slowly over the beach, and it was only about 30 feet above the ground, and they were maybe 20 feet from the UFO, so maybe 60 70 feet from it, and the guy had a good arm. He took a rock, hurled it up at the UFO, and it disappeared.
Yeah, yeah.
The rock never came back down, and I think it was just swallowed by the micro black holes. You don't necessarily see the micro black holes. They'll, except at night, when they'll be emitting visible radiation, but during the daytime you don't necessarily see it. Oh, and I might add one more thing. I'm sorry to go all off on these tangents here, but many people report on UFOs, Ben, that they see these big square windows that look like windows around the lower part of the UFO. Now, a lot of people assume that the astronauts that are inside the UFO are behind those windows. Nope. What that is I believe those big square windows that circle the circumference allow them to collide subatomic particles outside the surface of the UFO, and so they create that shroud around the UFO. That's the purpose of those big windows. It's the cupola or the dome on top of the UFO where the alien astronauts are located. They're in the center part of the UFO. They're not, the rim area is like the business area of the UFO where they collide subatomic particles to make KK gravitons and micro black holes. Anyway, that's that.
No, that's great. And I've just got two more quick things. With what we've been discussing, the fifth dimension and our fourth dimension, is all of this around us at inhabiting the same space that we are actually in? Okay. So that the fifth dimension is actually in the same area that we're actually in. We just have to harness being able to access it from here, or do we have to pull it from somewhere? I just want to be a little bit clear on you know, we've got our UFO sitting on the ground here, and he's created his blanket of KKs around him. Okay. So is all of this within the same thing, or as the slides indicate, you know, that they are separate, and we have to kind of get there?
Well, at the very beginning of your question, you said something very, very interesting. Is that five-dimensional bulk all around us? You bet. It's everywhere.
Yeah.
I can't. Of course, we can't think in terms of 4 spatial dimensions because our minds, our brains have evolved for a 3 spatial dimension planet Earth, and then one of time. But I can do an analogy, and you can see exactly what's going on. Imagine a flat piece of paper floating in that, or 2 of them side by side, floating in that 5-dimensional bulk. In this case, we can say it's 3-dimensional. The piece of paper is 2-dimensional, but it's analogous to our 3 spatial dimension world that we live in. Now, imagine that on the piece of paper, the creatures that live on that piece of paper are flatworms. Okay, those are the inhabitants of that piece of paper, and from their point of view, they're moving around and they can only see on the piece of paper. So they can see another flatworm a little ways away from them because they can send photons back and forth and they can see the other flatworm. But if you and I were in the 3rd dimension and we were just looking at them, they couldn't see us, but we could see them, you know.
Yeah.
But the interesting thing is this, that the interesting thing is this, that the piece of paper, every point on that piece of paper, every location, every mathematical point is connected to, or is right next to, the 3rd dimension. It's totally surrounded by the air of the 3-dimensional place that we live in, and so your original question there was, is it everywhere? You bet it is. It's everywhere. We just can't think in terms of 4 spatial dimensions, but it's there.
Well, that's what I suspected, and I just thought it might be good to clarify that for people as well, that that we are talking about the dimensions as being pretty much all in the same area, that we actually, that how connected it all is.
Yep. Oh, and Ben, could I interrupt for a
Sure.
second? You had mentioned about getting into the bulk. I believe that you had kind of had a question more or less about how they get into the bulk. I believe what they do, and this is very exciting too. It turns out that KK gravitons, okay, that I talked to the Kaluza-Klein gravitons, are expected when they create them at the Large Hadron Collider. They're not actually going to see them directly. The KK gravitons immediately go into the 5-dimensional bulk. Okay, so what does that mean? If you surround your craft with KK gravitons, then it'll pull itself off the weak membrane that we live on, our universe, and it'll pull itself into the bulk. Because it's basically gonna follow those KK gravitons. If you're surrounded a shroud of KK gravitons, those KK gravitons are going to want to go into the bulk, into the 5-dimensional bulk. So the UFO is just going to go like that, and that would explain why in the Phoenix lights down in Phoenix, Arizona. I'm losing my voice. A number of people, Ben, reported that sometimes when they saw the craft directly overhead, that parts of it looked transparent and parts of it look solid, and that's the reason why part of the craft is actually in the bulk and part is in our membrane, and they probably do that to make the craft much lighter when it's in our on our membrane, if you know what I mean. In other words, if the craft weighs 10,000 tons or 100,000 tons, they can put a chunk of the weight in the 5-dimensional bulk, and then just have the observation pod, the cockpit area in our space-time. Yeah. And that's what they're doing.
That's what they're doing. Just a couple of other quick points, and we could talk about this for hours and hours, and we'll wrap it up very soon. Just for people to have a bit of an idea that the amount of power or force that's required to enter the bulk, when we have massive suns that populate our dimension, and they explode, they invariably explode and or collapse, and black holes are created. Is that indicative of the type of energy that is required to do that from an energy perspective? And are those black holes bleeding into the bulk?
That's a very good question. The micro black holes will, when they disintegrate, will create Hawking radiation, like I mentioned, and but some of the energy, some of the particles of the decaying micro black hole, the KK particles, will indeed, as I mentioned, they will disappear into the bulk, and the physicists will know that that's the case, because when they examine all the see, the conservation of energy is important. That's a fundamental law of physics, and when they see what happens, Ben, they'll see missing energy. They'll see some portion of the energy is missing. That's the part that they'll know went into the bulk, and then they'll know that they created Kaluza-Klein gravitons.
Yeah.
That's what's. Yep.
Fantastic, fantastic. Well, look, just to maybe conclude our discussion today, maybe perhaps if you could just give us what your vision might be, say, for what we might see occur in just, say, the next 50 years.
Actually, I hope it'll be sooner than 50 years. How about I do 10 years?
Okay, you're pretty confident that we're that close.
Yep, I'm pretty confident. The reason I'm confident is because one way or the other, we're going to get this data. I'm the kind of person that I'm just totally determined. I have to get the spectrographic data. You know, whether Doug Trumbull helps us or whether I win the lottery or whatever, we're going to get it.
You're going to get it.
And my vision is this. The first thing that'll happen is UFO researchers, but with help from the scientific community, who unfortunately, unless they volunteer, they we'll have to pay them to do this kind of work. And but considering the economy in the world today is a little not doing as good as it might, there should be a fair number of scientists and physicists and stuff that are only working part-time or temporarily out of work, and we could hire them, and they have the expertise, and we might be able to get a bit of a bargain. They're just looking for any kind of work, and so we just might be able to hire them on board. And so my hope is this, that we get to the point where we hire some physicists and optical specialists and stuff, and we find out about a major wave of UFO sightings. Who knows? Maybe they'll be in Japan, the country of Japan, or they could be in Australia, and we'll send the teams down there. Not one team, but multiple teams, because we want to, and then we'll spread them out in the area. It could be 200 or 300 miles, and we'll have a team here, a team there, and a team here, and so on. And then if they get the data, and but multiple teams get the data at different times, and then we bring it back. Here's the plan. My plan is to get this data to Michio Kaku, the physicist at I think he's City College of New York, or NYU, or one of those colleges, and Michio Kaku wrote the foreword for Leslie Kane's book, or he wrote at least a recommendation or something. And so he's an open-minded physicist, but well respected. And if we can show Michio Kaku, Professor Kaku, if we can show him the Hawking radiation graph from multiple from multiple teams, that's going to get his attention, and from that point on, I think we're going to be in business. I think at that point, he'll go to the government, he'll probably take some of us with him, and the government will say, my God, this is it. And then once the government gets into it, then we'll really get tons of funding, we'll get the expertise we need, they'll confirm what we found, and then at that point, Ben, the sky is the limit, or should I say, the stars are the limit.
Fantastic, Robert. Well, look, thank you so much for your time today. It has been absolutely fantastic, and I just would like to conclude again by saying that Robert's book, Solving the UFO Enigma: How Modern Physics is Revealing the Technology of UFOs, is pretty much an essential read for anyone who wants to really start grappling with the concepts that are at the heart of ufology and really at the heart of the mystery. So certainly from Australia today, Robert, we do appreciate your contributions to us down here, and it certainly will go to an Australian audience, and will become a bit wider known down here in the southern hemisphere. And we wish you luck also at the International UFO Conference coming up, and I'm sure that'll be a great platform for you to get to a wider audience as well. So thanks again for your time.
Okay, Ben, thank you so much for having me on your show. I really appreciate this. And if anybody wants to buy the book, they can go onto Amazon.com and they can look for Solving the UFO Enigma, How Modern Physics is Revealing the Technology of UFOs by Robert L. Schroeder, and they'll find it. They can go Google it and they'll find it right away. And I'd really appreciate it if people can buy the book, because my wife is still mad at me for spending the money publishing it.
Well, I think I'll certainly be buying another copy or two, because there's a few people down here who I think definitely need to read it, and yeah, so we certainly will be doing that from here.
That would be great. And thanks again, Ben, for having me on your show. And let's keep in touch, because let's see how things develop over time here. I'll keep you posted on what I do, too.
Yep. That sounds fantastic, Robert. Thank you.
Okay, thanks so much. And we'll sign off for tonight.
Cheers.
Okay.